Hello, welcome back, and today we're going to begin 6.2, all about kites and trapezoids, all about their properties and all about the relationships between all the different segments in each of those figures. So first of all, let's review a little bit about quadrilaterals. We have all these different types of quadrilaterals: squares, rectangles, parallelograms, kites, rhombus, and trapezoids. Just a little piece of information. In the UK, they call it a trapezium, and in the United States, we call it a trapezoid. Okay. So today we're going to look at kites and trapezoids, which are two of the quadrilaterals. So first of all, looking at the diagonals of a kite. So first of all, a kite has two distinct pair of consecutive congruent sides. And so in other words, it has the congruent sides aren't opposite of each other. They're right next to each other. Okay, so there's two distinct pair of consecutive congruent sides. So consecutive means right next to each other. One diagonal bisects the other one. Okay, so this longer diagonal here bisects this one, not the other way around. Okay, so only one of them gets bisected. We have two non-vertex triangles. So if you think of a kite as basically two isosceles triangles sitting on top of each other, or I guess butt to butt, these two sides are congruent and these two sides are congruent, but they're not congruent to each other. Okay, so they're two isosceles triangles basically sitting base to base. One diagonal bisects both vertex angles. So this longer diagonal also bisects both of these vertex angles. So lots of information to know about a kite. Okay, and so let's take a look at all these properties. So what is the measure of angle AXB right here? Those diagonals always also intersect at a 90-degree angle. So this is 90 degrees. Okay, if AX is 3.8 right here, since this diagonal gets bisected right here, that means, I should mark this 3 right here. That means that this also is 3.8 over here. So 3.8 plus 3.8 would be 7.6. And so AC would be equal to 7.6. Okay. All right, let's continue on. In quadrilateral, PQRS is a kite with diagonals QS and PR. What is a measure of angle 1? So again, we know that this measure of angle 1 here where they intersect is 90 degrees. The measure of angle 2 up here, well, if this is 90 degrees, this is 90 degrees. So we have a 90 right triangle in here. So 90, right, 90 plus 35 plus that angle 2 should equal 180 degrees, right? So that 90 plus 35 gives us, what is that, 125. Plus angle 2 should equal 180. And then if I subtract that 125 from 180, I get my 55 degrees. So my angle 2 should equal my 55 degrees. Okay? And the measure of angle 3, these vertex angles, or these non-vertex angles, are congruent. Okay? And so angle 3 would be equal also to measure of angle 35. Okay? So down here in this little box, you may incorrectly assume that angles are congruent just from their looks. You cannot just assume anything in algebra is congruent from looks. They have to either be marked congruent or stated congruent somewhere, so be careful with that. You have to prove they are congruent. Okay? So next up is trapezoids. The definition of a trapezoid is a quadrilateral, because it has 4 sides, with exactly one pair of parallel sides. Okay, so these two bases here are the parallel sides. Okay? We call both of these top and bottom angles base angles. Okay, the bases are the parallel sides, and the legs are the non-parallel sides. Right? Isosceles trapezoid the legs are congruent. So these legs over here are congruent is how you get an isosceles trapezoid. So isosceles trapezoid, my legs are congruent. Each pair of base angles down here are congruent. And the top and bottom angles are supplementary. So these guys right here, these two angles A and D would add up to 180 degrees. And then my diagonals are also congruent. So lots of cool properties of an isosceles trapezoid. So looking here, Kaio designed a trapezoid-shaped roof. In order for the roof to be symmetric, the overlapping triangles, triangle DAB and ADC, must be congruent. Will my roof be symmetric? Well, if you look here, we know that these sides here are congruent. We know that would share a similar side, same side reflexive property of AD there. And then we know that if we have this angle here and this angle here, we know my base angles would be equal. And so therefore by angle side angle, we would have congruent triangles. And so yes, it would be symmetric. Okay. Given isosceles triangle PQRS, what are the measures of angle P, Q, and S? Since it's isosceles, we know that angle Q is 135 also. We know that these two add up to 180 degrees because they're supplementary. So if we take 180 minus 135, that gives us 45 degrees. So this base angle is 45 degrees, which means this base angle is also 45 degrees. Okay, so these are all properties of our trapezoids and kites. Given ST is parallel to RU, which means it's an isosceles trapezoid because these legs are also congruent. If this is 47, that means that that is supplementary to SRU. So 180 minus 47 degrees gives us 133 right here. Whoops. Which means our base angle here is congruent to 133, which means that the angle TUR is 133 degrees. Okay. All horizontal beams of a high voltage transmission tower are parallel to the ground. The top section up here is an isosceles triangle, and also this midsection here is an isosceles triangle. If the measure of angle 1 is 138 degrees up here, what is the measure of angle 2? Well, if measure of angle 1 is 138, that means that this one is also 138, right? And then 138 and angle 2 are supplementary. So if I take 180 minus my 138, that leaves us with 42 degrees, which means my angle 2 would be 42 degrees right here. Okay. All right, my midsection here, it says one cross support of the center of the tower measures 4C plus 3. Right here, my other cross section measures 6C minus 5. What are the length of each cross support? Well, we know that these cross supports are equal because diagonals of an isosceles triangle are congruent. So we're going to set up an equation here that 4C plus 3 is equal to 6C minus 5 because they're equal in length. So then I can just solve, first of all, for C. Let's find out what C equals. So 3 equals 2C minus 5. And then I'm going to add 5 to each side. 8 equals 2C. Divide by 2. 4 equals C. But that's not really what I want to find, right? I want to find the length of each side. So if I plug in 4 here, I get 4 times 4 plus 3, which is 16 plus 3, which is 19. And since they're congruent, I know that both of these sides are 19. So 19 would be the measure of each cross member there. Okay, so now we're going to take a look at this mid-segment of a trapezoid. Mid-segment is basically if I find the midpoint of each leg and connect it, that is a mid-segment. And the length of the mid-segment is basically the average of the two bases. So if I take my base plus my base and divide it by 2, that will give me my length of my mid-segment right here. Okay, so right here, Paxton makes a trapezoidal handbags for her friends. She stitches decorative trim along both the bottom and the top, and then on both sides. Let's see how it says on the sorry, decorative trim on the top, middle, and bottom of both sides of the handbags. How much trim does she need for 3 handbags? So first of all, we need to find the length of this mid-segment, right? So the mid-segment is going to be 6 plus 9 divided by 2, which is going to be 15 divided by 2, which is going to be 7.5. Okay, so let's find the total stitching for one side is going to equal 9 plus 6 plus 7.5, which is going to be 15 plus 7.5, which is 22.5. Okay, so for one handbag, that's going to be double that, right? So 45 inches. So if she needs 3 handbags, she's going to need 4 times 45 inches, which is going to be, 3 handbags, 3 handbags, 3 times 45, which would be, what is that? 3 times 45, 135 inches of stitching she will need. Okay? Okay, so given this trapezoid, what is KL? So now we actually have the mid-segment. We need to go backwards and find the length of KL. Well, first of all, this tells us that 4/5 of XY is this measure of JM here. So I'm going to go ahead and plug in 4/5 times my XI, which is 25th or 25. This 5 will go into 25 5 times, and 4 times 5 is 20. Okay, so the measure of this is actually 20 right here. So I'm going to take my little formula. So 20 times, I'm going to call this X up here, or 20 plus X divided by 2 is going to give me my mid-segment, which is 25. Okay. Then I can just solve this. I can just multiply by 2 on both sides. It's double my mid-segment here. So 20 plus X equals 50. And then I'm just going to subtract my 20 to find my length of my mid-segment, or my other side, which is going to be 30. So this side up here is 30. This side is 20, and that side is 25. Which kind of, you could probably do that in your head, but I want to see some work. Don't forget that, okay? All right, so here is all my summary of my kites and my trapezoids. You have a little Excel in Google Classroom, and oh, there's my cute little trapezoid. This is the way it's trapped, okay? You have an Excel in Google Classroom for 6.2. Make sure to show all your work and answers and attach it, and I will see you all in our next Zoom. Have a good one. Bye-bye.